Good afternoon, everyone. So I hope some of you had a chance to grab some food. Actually, you can see some people eating in the audience. So we'll have another break after this session to grab some lunch. We're actually running lunch across a couple of sessions to make sure we can maximize the content that we have for you here today at the London Summit. My name's Steve Bryan. I'm in our technical and developer evangelism team. And what that really means is that AWS pay my salary, but I really work for you. My job is to really work with the community of technical professionals and developers here in the UK and Ireland to really kind of understand how best to engage with this community of people that we work with. So I do a lot of events speaking like this, but I also love speaking to developers and tech pros and understanding how we can feed back information from yourselves back into the business so we can improve the experiences that we give to our technical community. My Twitter details are up there. Feel free to direct message me, or you can email me at sbryan@amazon.com. I'm always open to hearing feedback from customers on how we can improve the way we market to our customers and how we provide experiences for developers. I'm delighted to be joined by Bjorn from Drax today. He'll be joining us on the stage a bit later to tell us about their story around how they've driven some digital transformation using AI. So let's dive into the topic. So if I asked you, how important is it for your company to invest in machine learning and AI? Some of the answers we typically get are, we're not a machine learning company. It's not really central to our business. We're busy fighting fires. We don't, we have other things to worry about. But when we ask customers, how important is it for your organization to build better products and deliver better customer experience, we unanimously hear that is our number one priority. And here at AWS, we think that's actually the same thing. To drive better experiences for your customers, really in today's age, artificial intelligence and machine learning is going to be key for you being competitive in the markets in which you operate. And you may have seen this picture before. Don't know if anyone knows what this picture is, but this is a picture of people working on the London Underground in the 1950s, 60s, that kind of time frame. They were actually processing basically used tickets from the Underground to identify the least used routes on the London Underground. This is 1950s data analytics in action. So people have been trying to get insight from data for quite a long time. But now we see this kind of flywheel for data where customer experience is accelerated through more data, through things like clickstream analytics, social media, and you're able to do better analytics, provide better outcomes to your customers, which ultimately drives more people to your product. So this flywheel of data is driving a huge transformation in businesses around the world, and AI and data analytics is underpinning that. But one common myth we hear about AI and machine learning is that AI is the flavor of the month. You see humans are underrated here as a headline on Fortune magazine. You hear this kind of buzz around AI machine learning. It's the flavor of the month. It's the hot topic. Is it really a real thing we can realize today? Well, actually, AI may be the flavor of the month, but it's a technology that was, the term was first coined by an American computer scientist called John McCarthy in 1955. And he proposed a conference in 1956 called the Dartmouth Conference, which was the first known artificial intelligence conference back in the 1950s. So why is a technology so old taken so long to take off? It's this kind of 60-year rise of artificial intelligence. And typically when you look at technology, if it isn't adopted within the first kind of 2 or 3 years of its kind of inception, it typically dies of death. Does anyone remember the mini disc? There's not huge broad spread adoption of technology. It typically dies off and is no longer relevant, and something else kind of underpins it. So why has it taken 60 years? This data on this slide, I believe, is only from about 10 or so years ago, maybe 12 years ago. I think it says 2007 there, yeah. So these are the trend of the term artificial intelligence. So why has it taken 60 years for us to see this meteoric rise in the term artificial intelligence? Well, there's 4 key reasons for that. The first one is algorithms. We've seen a commoditization of algorithms. The ability to get hold of algorithms that are open source or community driven the access has been made much more available for developers and data scientists to access algorithms. Things like convolutional neural networks were invented in the late 90s, but they're now common technologies that are used for deep learning and machine learning work. Data, we touched on this earlier, but data is super important to the ability not just to capture data more through Internet of Things or sensor data, but also the ability to store data at low cost and at scale very easily through things like Amazon S3 makes it very easy for you to access this data and have it closely coupled with the compute that you need to process that data. GPUs and acceleration. We've seen a huge amount of invention around GPUs and acceleration, and the accessibility of this technology is just becoming easier and easier every day. And obviously cloud computing has brought the elasticity and scalability for developers and researchers to be able to have access to low-cost compute and storage on demand, at scale, at their fingertips, whether you're the world's largest companies like enterprises like Sainsbury's, who we saw on stage today, or whether you're a developer in your bedroom trying to build the next startup, you get that same level of access. So we've almost democratized the access to technology to get started with building intelligent applications. And what we see with our customers is that AI is the new normal. And what do we mean by that? Well, by most estimates, the gross domestic product of the world in 2018 was about $80 trillion. This is a measure of the overall economic productivity of the whole human rate. Many social and analytical organizations have made growth predictions for the GDP to increase rapidly over the next decade and beyond. And a recent study, I think it's from PwC, they estimate that by 2030, the GDP of the globe will grow to 112 trillion by 2030. So this is a huge growth in the GDP. And actually about 15.7 trillion of that is estimated to be improvements and net new value that's been generated in the economy by the use of AI technology. So if you put that into kind of human perspective, that's 14% of human productivity in 2030 that is adding that value. So basically what we're saying is the builders that embrace AI will be the kind of engines of human acceleration for the next 10 or so years of our global economy. So let's look at defining AI. So if you look at defining AI, popularly, we see here it's when a machine mimics cognitive functions that we associate with other humans, such as learning and problem solving. And if we define the AI from a computer science perspective, it's the study of intelligent agents, i.e., any human agent that perceives its environment and takes actions that maximize its chances of success at some defined goal. But we understand that there's often some complexity around the different terminology that you might hear when it comes to AI, machine learning, deep learning. These terminology can sometimes be quite confusing about what the difference is. So, as the name suggests, artificial intelligence can be loosely interpreted to mean incorporating human intelligence to machines. It's really the broader concept of the kind of computers trying to interpret human intelligence. Machine learning can be loosely interpreted to mean empowering computer systems with the ability to learn. So the intention of ML is really to enable machines to learn by themselves using provided data and make accurate predictions. It's simply a technique for realizing AI, so it kind of is a technique that underpins artificial intelligence. And then deep learning is this new era of machine learning kind of research, which has been introduced with the objective of moving machine learning closer to one of its original goals, which is artificial intelligence. So you hear of things like artificial neural networks or convolutional neural networks. These are complex networks that actually learn through multiple layers, kind of like a human neurological network, kind of to mimic that neurological network that we have in our brains. But often you'll hear, and I think I just said it, AI is about predicting stuff. It's not just about predicting using historical data. There's been lots of advancements in machine learning and different types of machine learning. It's much more than just predictions. So there's various different types of machine learning that we see. Firstly is supervised learning. This is getting better at finding the target. This is using historic data to try and predict what's going to happen in the future. And then we have unsupervised learning, which is kind of this assume nothing, question everything approach, where you can uncover hidden patterns and relationships through this unsupervised learning, where you don't necessarily have all the data up front to create those predictions. And then we touched on this in the keynote earlier, but we see some enhancements in technologies such as reinforcement learning. Reinforcement learning is really interesting. It's actually what powers our deep racer cars that you saw in the keynote earlier, these 18th scale race cars. And it's kind of like giving a dog a treat, to reward them for the work that they're doing. So it's reinforcing good actions with the rules to maximize the high-performing behavior that you expect. So in this example, you would keep, rewarding this child as it starts to walk and it starts to run, and eventually they become Usain Bolt. So that's kind of, through reinforcement, you never know. My son plays football. I'd like to hope that if I keep shouting at him from the sidelines, one day he may be, the next Harry Kane or something, we'll see. So lots of different machine learning technologies and lots of different concepts that are used. And quite often we get asked, well, what does Amazon know about machine learning? What does Amazon know about artificial intelligence? It's all well and good you telling us about this theory, but why should Amazon be able to help me with AI machine learning? So over kind of 20 years of running Amazon.com and the associated businesses, we've actually done a lot of work around engineering around machine learning. We've built a lot of expertise in our business around machine learning. Obviously, the most obvious type of machine learning you see from Amazon is the recommendations engine in Amazon.com. That's the typical kind of story that everyone talks about. And there's actually a paper from a couple of years ago around, it was published in the Internet Computing magazine called 2 Decades of Recommender Systems at Amazon, where we actually wrote an academic paper about the 20 years of recommendation system experience we had and how that applies to modern machine learning techniques. So if you're really interested in that, I'd encourage you to look that up. But there's many other places that we look at machine learning. If you look back to a few years ago, this is Amazon fulfillment. So this is a video of a fulfillment center in an Amazon, for Amazon logistics. And a few years ago, we were taking these goods and we were sending them around, and we had these people that were packing items and picking them up and walking around the floor to deliver them to the packers that actually pack them into the boxes and send them on to the next step. But we realized that was inefficient, and it wasn't the best use of technology or the people that we had in the organization, to be quite frank. We knew they could be focusing on much more higher value activities. So what we did is we have a part of our business called Amazon Robotics. This is a little robot inside our fulfillment center. And these robots are really cool. What they do is they drive around the fulfillment centers and they pick up the trolleys of goods and they take them to the packer to basically just, they sit in a seat, they're stationary, they're not walking around the floor anymore. They just pick up the item, scan it, and pack it into the box for you to receive at home. Now, there's a ton of machine learning work and intelligence that goes into running such an operation. One of the interesting things about these trolleys of goods is that we pack them completely randomly. Through research, we found that it's much more optimal to pack these randomly. So you may have pencils next to nappies, next to, I don't know, golf clubs. These things are packed completely randomly, and we find that actually from an optimization perspective, packing goods randomly is much more effective. And then also these, the robots, they're pretty cool. It's a cool Internet of Things story as well. But you can, if you're doing maintenance, for example, on the floor, or you need to walk across the floor, you can wear this wristband, and the robots will avoid you if you walk onto the floor with the wristband on. The robots will dodge you and won't crash into you as you're walking along the floor, which is quite interesting. And then we also have a machine learning algorithm that works out where does the robot take the trolley back to? Where is the most optimal place for the predicted future orders that we have in our system? Where does the robot take the trolley back to once it's done, once the packer has finished kind of picking the item and packing it? So a kind of cool robotic story there, but a lot of IoT and machine learning inference plugged into that as well. Another example, which I don't have a video on, is Amazon Go. Has anyone seen the Amazon Go store? So a few hands. Not very popular in the UK because we don't have them here at the moment. But believe it or not, Amazon are building bricks and mortar grocery stores in the United States, and we have 5 of these stores around the United States. We started in Seattle, and these stores are great. You walk into the store, you pick up everything you need, and then you walk out again. And then you just get a receipt on your phone that says, you bought a chocolate bar and a can of Coke, thanks for coming, take some money out of your Amazon account. And there's a ton of invention and machine learning that goes into things like computer vision and object detection and various other kind of algorithms that I can't talk about too deeply, unfortunately, around that technology. But you can imagine the amount of intelligence and research that goes into building such a sophisticated model. And actually, from a cultural perspective, it's really interesting because Amazon set out to do quite a lot of things that we call these kind of unstore experiences in the early days, where, if you go to a traditional supermarket, you will walk around the store to find milk, for example, or bread. They're always in the very back corner of the store, and you walk past all the distractions before you get there. We surveyed customers and found that actually putting our customers first, they just want to get the items that they need and they want to leave. And that spurred inventions of things like one-click buy on the Amazon website. But also we see that being really popular with these Amazon Go stores, where people don't want to line up, people don't want to wait in line, they don't want to have to worry about paying for their goods, they just want to walk in, pick up what they need, and leave. And it's actually I was part of the beta program, so I went to Seattle, was taking stuff off the shelf, putting it in my jacket, trying to trick the system as best I could. And it was, much to my kind of disappointment, it actually sent me a very accurate receipt when I left the store. And then I thought, well, this is actually a pretty underwhelming experience, because I just walked into a store, picked some stuff up and walked out again. It's kind of the way shopping should have always been. So it's lots of invention inside the broader Amazon business. And every day we're applying new improvements to our Amazon business. And then through AWS, we're providing those experiences to you as customers. This is a really interesting computer vision story. This is something called Amazon Scout. What we did is we wanted to basically, the recommendations engine at Amazon has been running for years, and it's typically done on historical data and past orders. But we wanted to make a kind of visual version of that. How can you can tell us products that you like the look of, and then based on that kind of computer vision technology, we can now propose products that look like products that you like. So we're now looking at it not just from a past purchases perspective, but we're looking at it from a, what are your tastes around the way you like things. These are some vases here and things for your house. So we can actually propose products that we know you think are, visually compelling as well. So lots of machine learning technology across the Amazon business. And as we've been through this journey, we've noticed a few things, and our customers in AWS have noticed a few things. The first thing is that ML experience is rare. It's a very up-and-coming trend, but if you were to look at any research around technology adoption, data science is probably one of the hottest careers you could probably adopt right now, but it's also one of the ones where we have a bigger skill gap in terms of getting experts that can help us do data science and machine learning for our business. We also found that whilst the skills aren't there from a data science perspective, building and scaling this technology is hard. It's really hard to scale things like the infrastructure required to run machine learning models at scale in terms of training and the huge amounts of resource required, but not only training for inference as well. If you're doing predictions, and let's say you're doing something super important like faculty in the keynote that were talking about their algorithm for detecting Daesh propaganda videos, that's super important, and you need to make sure that's available and up and resilient. So now you're not just focusing on data science, you're thinking about broader infrastructure and architecture principles about how do I build resilient systems that never fail. So whilst it's difficult to scale the machine learning training, it's also very difficult to make sure that in unpredictable times that we live in, that inference of these machine learning models is scalable and resilient to failure. And then operating models in production is time-consuming and expensive. We're not only building resilient architectures to host these solutions, we actually see customers struggle with operating them at scale, much like non-machine learning workloads. Patching, operating, firefighting takes up a lot of IT operations teams' time. So it's super time-consuming, it's super expensive. So what we saw was there was a lack of cost-effective, easy-to-use and scalable machine learning services. And what we wanted to do was try and solve some of these challenges for our customers. And if we dive a bit deeper into the actual challenges with machine learning itself in terms of the typical ML workflow, even for seasoned practitioners and data scientists that are experts in this space, things like data acquisition, data labeling, framework selection, scale-out training, hyperparameter optimization, model tuning, testing, simulation, inference. There's so many things you have to think about when you're scaling and building machine learning models. These things are really difficult. I forget the percentage, but it's over 60 or 70% of time that data scientists spend is actually on data engineering work. That means they spend most of their time getting their data ready to do machine learning. So they have unstructured, semi-structured data in their data lake, and most of the time is spent just getting the data ready to get intelligence from it. So we saw that as a huge problem. So we set out as our mission in AWS to put machine learning in the hands of every developer. So it's a pretty broad mission, but we're well on the road to getting there. And what we looked at building was a machine learning platform that's accessible whether you're a data scientist, a software developer, or an IT professional just looking to get started. Maybe you're not a developer, maybe you're an IT architect or an IT manager. How can we make it as accessible and easy as possible for you to get started with machine learning? Because we really truly believe that without machine learning and AI, you're going to lose competitive edge against your customers, because they'll just be doing that. They'll be doing that already, and they have better customer insight, providing more personalized experience for their customers, which in today's world we know is super important. So when we look at the machine learning stack from AWS, and this is really taking those, in many cases, taking those 20 years of experience of machine learning at Amazon and externalizing that through AWS, through services that you can use to, whether you're a developer, data scientist, or whether you're kind of what we like to call an intelligent developer who works in this middle ground where you want to go a bit deeper into building your own custom algorithms, but you don't necessarily need to want to worry about the infrastructure underneath. So we look at this three layers. At the very bottom layer here, we have machine learning frameworks and infrastructure. And Matt touched on this briefly in the keynote earlier if you were there. But this is the low-level infrastructure that kind of data scientists want access to do machine learning at scale. This is what faculty are doing if you're in the keynote. This is the kind of level of infrastructure they're using. They're running open source machine learning frameworks like TensorFlow, MXNet, Keras, PyTorch on the low-line infrastructure. And we provide GPU instances that are optimized for machine learning. We also provide, I think it's worth mentioning that quite often you assume that training deep learning and machine learning models requires GPU compute, which is reasonably expensive. But actually, we have many customers that actually train on Intel-based architectures, on x86 architectures, for better cost performance, and it meets the requirements for their training needs. So not everyone has to go, super expensive, super high-end with the GPU infrastructure we provide. We also have FPGA instances that provide field programmable gate arrays, which are basically silicon that you can program to do very kind of low-level engineering. And then if you want to take your machine learning models and run them at the edge, so take an example of let's say I'm going to recognize you when you get into your car, and I'm going to adjust your seat accordingly because I know it's you and not your wife or your husband, whoever it is. So I get in the car and I go to do this image recognition, and it says, can't connect to the internet because I'm in an underground car park, can't do inference on my machine learning model, so you're like, can't adjust the seat. I mean, sure you could do it manually, but just take that as an example. Well, with AWS Greengrass, we actually provide a runtime for edge devices where you can take these containerized models that you train in the AWS cloud, deploy them to the edge, and you actually do inference at the edge offline. So the ability to take these machine learning models and run them at the edge using AWS Greengrass. And then I'm just going to focus on the top layer because I'm going to dive a bit deeper into the middle layer. The top layer here is what we call our ML services or our API level services. And these are pre-trained machine learning models. To use these services, you need no machine learning experience at all. If you're a software developer, you can plug into one of these pre-trained models, whether it's for image recognition, text-to-speech, speech-to-text. We actually added two new services called Forecast, which does forecasting, and Personalize, which is that recommendations engine we spoke about earlier, externalized through a personalization service. And these are slightly different to some of the other services that, like recognition, which is completely pre-trained, where you actually provide your own data. To do personalized recommendations, you need to provide some data from your business to do that learning. So you provide us your data in an S3 bucket, but we take care of all the complexity of hyperparameter tuning, choosing the right algorithm, deploying and scaling the machine learning model for you. So once you provide that data, put it through a cycle of training, which we take care of all of that heavy lifting, you can then do inference and get personalization and recommendations on your personal data through personalized. So slightly different in the sense you do need to bring some data, but very personalized and still no machine learning experience required. And then in the middle tier here, we have this product called SageMaker. And SageMaker is really a platform for developers that want to do a bit more. They want something that's a bit more personalized than what you get with, for example, the AI level services. Let's say British Airways, who were mentioned again in the keynote earlier, where they're doing predictive maintenance for A380 aircrafts. This is where SageMaker, they use SageMaker to train their custom models for their specific workload. It goes a little bit deeper than what they could do with the pre-trained machine learning services. And SageMaker comes in 3 parts. The first part is the ability to build machine learning models. And this comes in the way of Jupyter notebooks. If you're a data engineer or data scientist, you probably use Jupyter. It's an open source collaboration and editing tool for building machine learning code. And the Jupyter notebooks, we provide a hosted Jupyter notebook experience. So we take care of hosting the Jupyter notebooks for you so you can access them in the cloud. And then when it comes to training your models, we have a very simple API where you can say, I want to train this model on 10 instances of this size, go ahead and train it. And we take care of all the heavy lifting of spinning up the containers, deploying TensorFlow, or whichever algorithm you choose, a framework you choose. And we take care of scaling out those containers, doing the training for you and telling you when it's done. And then finally, for hosting your machine learning models, we have the ability to just one click and we deploy a simple API that you can use for inference, and we will take care of auto-scaling those instances under the hood to make sure that, based on workload, your inference is scaling as best it can under the hood. So SageMaker is this platform that gives you that bit of extra functionality beyond the pre-trained services. And it's where we see a lot of our customers getting that real edge in terms of taking their own data, using custom algorithms, and getting more insight for their business. SageMaker comes with a ton of built-in algorithms, things such as object detection or image classification. And these all come as containers. So they're containers inside SageMaker that you can choose to use as pre-built algorithms. But they're just Docker containers. So you can bring your own containers as well if you've got a custom algorithm or something you want to run on SageMaker as well. And you can choose, SageMaker will take care of the scaling of that for you. You just bring along your own container with your custom algorithms on it. So we're seeing our customers build innovative ML-based intelligent systems, and at quite a big scale. So just a few customer examples before we dive deeper into one specific customer. Intuit, they build a popular accounting software called QuickBooks in the United States. They've been able to accelerate their development using SageMaker. They've been able to take the time from development from 6 months down to less than 1 week to develop one of their specific solutions. That's a 90% reduction in development time. So this isn't necessarily going deep into the weeds of the algorithms they're using or anything. This is just taking away that heavy lifting that customers often face with scaling and building and deploying infrastructure, and specifically around machine learning algorithms in the cloud. They've been able to take SageMaker and make that much easier for them. Formula One, great reference to talk about. Formula One is a very data-driven sport. Very competitive sport, and where milliseconds count. During each race, there's 120 sensors on each car. They generate 3 gig of data, and there's 1,500 data points are generated each second during a Formula One race. Formula One pump all this data into the AWS cloud, and they use SageMaker with the kind of real-time data to make predictions. But they've also got 65 years of historical race data that they've trained their custom algorithms with to try and make predictions on races real time. So if you're watching Formula One and you see those insights in the bottom of the corner of the stage, it makes predictions on the future of the race. That's all powered by machine learning on AWS and Amazon SageMaker. So quite an interesting reference there. This is one that's really fun that I like. This is a company in Korea, actually. They're called Kuhmo Petrochemical. And they wanted to enhance the safety in their factories and make sure that people were wearing hard hats in their factories. So they worked with a partner of ours called Megazon in the APAC region. And they used TensorFlow on SageMaker to train their machine learning model to detect if someone was wearing a safety helmet or not. And then they also partnered up with image recognition through AWS Recognition. They felt, why do the heavy lifting of recognizing if there's a person in the picture or not, when Amazon already have a service that does face detection for me? So Amazon Recognition does the face detection, and then TensorFlow detects whether that face is wearing a hat or not. And then they use Amazon Poly, which is our text-to-speech service, to actually then shout at people, basically, across the factory if they're not wearing their helmets. So quite a nice integration of some custom-built models along with pre-built models from AWS as well. So we have tons of machine learning going on AWS, and the message here really is this is a path well trodden. This is something many customers have done, and we hope you can learn from their experiences. And actually, to dive a bit deeper into one of our customers here in the UK, I'm delighted to welcome Bjorn Renke from Drax, who's the Director of Smart Metering, talk about how they've used Amazon AI services to drive transformation in their business.
Good afternoon, everybody. My name is Bjorn Renke. Absolutely thrilled to be here. When the Amazon team contacted me to ask me if I would speak at a breakout session at the summit, I expected 20 people and a flip chart. This is quite a difference in view. Fantastic, absolutely terrific. Okay, so I'm going to talk about Drax power for only 1 minute. So what we do in Drax is it's a power station, a power company. We use massive coolant towers, but we actually use biomass pellets that we get from United States forests, which are working forests, so we take out less biomass than we put in per year. Our trees grow over 10 years, and we turn those trees, which represent the lungs of our business really, capturing carbon via photosynthesis, into rather glamorous looking biomass pellets like that. Then we pulverize them, burn them, turn water into steam, and fire that steam through 6 massive engines and turbines up in the north of England, which is how we generate 15% of the UK's renewable energy. It's something I'm very proud of. So the biomass itself, carbon cycle is already very positive, but in that chimney you just saw, we actually carbon again, so we captured carbon twice. And I think nowadays that means we are well on our way to become one of the first carbon neutral companies, energy companies, which we then sell to business customers via our 2 brands, being Haven Power and Opus Energy. So I think it's absolutely terrific to be involved, and I'm very proud to be associated with Drax. And I wanted to just introduce what we do. So what's next is to give you an overview of our systems. A company like Drax employs systems thinking, just giving you a little bit of an overview as to how that builds up. So on the left-hand side, you've got the base system, which is the system of record. In there, you've got a billing system, you've got finance procurement system, HR systems, sometimes even metering data flows. Could not be more fascinating, and is probably not a strategic differentiator anymore. But building on that, you've got the so-called system of intelligence, and that's where the fun part happens, because in there you've got data science algorithms, reporting infrastructure, data lakes, data warehouses. That's what we call the brain of the Drax retail arm. And on top of that, you've got a system of engagement, which includes a hopefully easy, intuitive, easy to absorb, multi-channel engagement layer for our customers, so that you can switch between different channels, have the same experience. Now, what is interesting about this is that each of those system groups are owned by individuals. I'm owning the middle one, and it's actually quite good fun. So if you interact with representatives or owners of the other systems, actually can add a lot of value. And actually, the interaction is a very positive one. We have regular meetings about that, and therefore those systems glue together. So the system of intelligence I tried to personify for this audience here by means of a robot sign. I got some feedback. It looks nothing like a robot. So the parents of you will realize that it's actually very similar to Eve in WALL-E, but the non-parents won't know that. So look out for that. That's supposed to be my personification of the system of intelligence in the next slides. Now, to get there, we had 3 phases. Number 1, to create a trusted data set that is reliable, deduplicated, up-to-date, somewhere accessible, and that I expect to be actually quite easy, right? But I'll talk more about that later. Now, the trusted data set itself is the foundation for the system of intelligence, because without that, without a high-quality data set, you are going to have difficulty with the later phases of this. Second phase was supposed to be federated insight everywhere, accessible to everybody that needs the access, from operational layers to finance individuals, yes, the data scientists too, but to move away from push reporting via KPI scorecards, which seems to be a little bit outdated, and actually give the insight and the data into everybody's hands whenever they need it. And suddenly, you don't have a singular inside entity in your business anymore, but hypothesis testing and fact-based decision-making is distributed everywhere. It's much more powerful, much more federated. And the last stage is where the real fun happens, because that's where the machine learning and automation and tooling process automation can happen, but only if you master the first two phases, which is our approach. Before I go into what our system setup actually looks like, I wanted to demonstrate how our customers are using it. Firstly, starting with the external, our main customer groups. Now, we sell energy to business customers only. It's not domestic, it's non-domestic customers. And we've got such a broad variety of business customer types. Here's an example of a coffee shop, but we have schools and gyms and pubs. So that means that our customers, which are so diverse, expect a degree of tailored interactions with them. If we do not tailor our interactions and suddenly accidentally benchmark a church with a pub, however funny that may be, it will be unwelcome, and it's even patronizing for some of the customers. So our customer groups, highly interested in different use cases too. It's not only about efficiency, it's also about security. Maybe there's safety-related messages. Maybe people are interested in their competitive advantage. So if I was a coffee shop owner, I would want to know that the other coffee shops in my area in 2 miles, actually 70% of them open maybe 30 minutes earlier. So you would want to know that, wouldn't you? Because you could adjust your business processes for that. So competitive assessment is now possible, and I think the use case have to be tailored to each customer group. Internal customers, we have team leaders and frontline agents that are currently having a lot of question marks around their head because the base information is not yet available. So what we're working towards is things like, how do customers feel about my team's interaction with them using some of the voice analytics? Sentiment analysis is now possible at scale. So that's something that we will deploy to our frontline agents. And prospecting or productivity analysis is important too. Some of our customers have an energy consumption profile that pretty much directly matches a solar production profile that could actually predict how much or how long the payback period is for a battery or for solar energy. And that is something our teams need to be able to do. And our little robot can help with that. Right, our frontline agents approach calls which may be a multi-channel call. So without understanding what experience the customer already had in the other channel, you feel like, as a customer, you feel like you're restarting. And therefore, that's always really annoying, not only the identification and verification, but also what the customer actually looked for. So for us to be able to help customers with the background of the previous customer journey, maybe previous complaints, is highly relevant because you can have a more tailored, more ready, and respectful conversation with your end customers. And it's about time that we give our own internal teams such capability. Otherwise, it's just tedious. Right. When it comes to our leadership team, I don't know about your company, but some companies, I'm not suggesting it's happening in Drax, but some companies spend a lot of political and emotional energy discussing their competing data sources. Right, so which data source is actually correct? Is it your spreadsheet? Is it my spreadsheet? What is actually the financial position at the end of the year? So it would be much better to have a step away from month-end reporting or KPI reporting and have real-time data in the hands of everybody. So the interest in having a real-time central data set of our leaders is significant. Last but not least, there's a couple of future scenarios. With the arrival of automated meter reads and smart metering and the establishment of a smart grid, which is one of my jobs, I cannot wait for this to happen, which is assistant-based switching, maybe even auto-switching, that is based on principles and your value set and your budget, that is made easier by an end-to-end technology automation, which at the moment we don't do. The amount of inertia when it comes to energy switching is significant. So the question is, how can we help our customers through that and allow them to switch to Drax even easier? And I think for that to be assistant-related or assistant-enabled is no longer a futuristic idea. Actually, I think it's quite easy to do. So to show you then what our system looks like. On the left-hand side, you see the traditional data set. So we've got so many different data sources which are fragmented, sometimes even duplicating data sets, updated in unequal frequencies, and difficult to enrich with strategic acquisition of data sets. So maybe you want to buy social media data or weather data or whatever data. So it's a fragmented data set. We put all of that into one data lake, which is an Amazon S3 bucket, and then we follow two routes. Now the bottom route is very traditional. You've got an extract, transform, and load layer for which we use AWS Glue and Matillion as well, depending on the use case. Going into the from the unstructured data lake into a structured data warehouse for which we use Redshift, much more accessible, much more quicker, and then use reporting and visualization tools for that, and for which we use Amazon QuickSight. So far, so good. I expected the first stage of the data being ingested into the data lake to be very easy, but that takes forever. I expected it to be copied and pasted and just pop it across into the data lake, but to do that properly will enable you to have much greater quality, much greater consistency of the data set later on, and it's not a quick thing to do. The benchmarking I did was that probably takes 1 to 1.5 years. I thought, no problem, I will beat that, no problem at all, but we're still doing it, so not complete. On the top you have the analytics platform, and Stephen already talked about the importance of the role that Amazon SageMaker can play. Now that's one of the new toys in our business, and I think it creates a lot of new energy for our data science teams to learn about it, to develop their careers around it, and to participate in exploratory data science in the way we haven't done before. But the route continues with a development of Amazon partner InnoWisdom. So InnoWisdom helped us kickstart some of the data science work that we did, generating value from, I want to say, within a few days, helping us understand and learn what is needed to extract maximum value out of such data lake, overcome issues like incomplete data sets. So the partnership model, and especially InnoWisdom, worked terrific for us. I recommend it. Okay, so 2 example cases I wanted to share with you. And this is the hometown of Sherlock Holmes, so why not have a consumption analysis test with you? So here you have an annual energy pattern, a consumption of a customer. Now this is a domestic customer, and in there you could already practice and tell me what kind of customer it is so that you can tailor your interaction with that customer. So it looks like you've got a bit of a base load. It looks like it's around about 400 watt, and that seems to be the base load for the oscillation of a fridge motor, right? But that compressor of the fridge is too big to just be for a single household. It seems to be like a family-sized fridge, which I know you know already. But then you've got other clusters, interesting clusters forming. So yes, you seem to have a family holiday that happens in springtime, but you also have a family holiday in summertime. Seems to be some sort of family. It coincides with family holidays. But then you've got interesting clusters around the 2.7 kilowatt, or even better, the 3.7 kilowatt. Now the 3.7 is slow charging for an electric vehicle, and those clusters are very clearly associated with slow charging of an electric vehicle, whereas the 2.7 clusters are very much around family appliances like washing machines and dishwashers. So what that actually means is that you have here a family set of appliances with an electric car, seems to be with small kids, depending on the family appliances clusters and types. And that is something that allows you to tailor the customer experience. Now, before you take too many pictures, that's my data, otherwise I couldn't share it, right? I still don't know what happened in the middle of my summer holiday. Some of my neighbors seem to have some sort of party. I was at the end of the world, only to find that I have a spike in energy consumption. Still not quite sure. Now, a good algorithm would be able to tell you what that was and which neighbor it was. Right, so second example is about anomaly detection. Anomaly detection, now it's much talked about example, but I want to show what we are doing with it. So on the left-hand side, you've got standard industry profiles, and there's about 80 of those, I think 80 to 90 or so. which example showing here the really predictable banks, open up at 9, close at 5, a very kind of a standard data set, but then also hotels with their kind of evening peak, and then a pub as well. So there's a whole host of those, including gyms and schools and churches. That means that a standard profile of such a customer group is reasonably predictable via time series analysis. And on the right-hand side, you see a standard oscillation of energy consumption. Now, that's not really rocket science, has been around for decades, but it's also easy to spot with a naked eye that something anomalous is happening, but not if you've got 2 million customers. You need to ask a machine to do that. Otherwise you're not going to make it. You need to point a machine at it, and now that we have cloud-based computing, that is actually possible. So the time series analysis here at scale, after the first few oscillations, shows that there's a deviation with beyond Six Sigma confidence that something untoward is happening. And you need to have an alarm-based system that says, hang on a minute, here's a customer group of 100, 200 customers per day. Something seems to happen. And depending on the anomaly type, here we say deviation from the time series, it could be, like in this instance, a change of tendency. Now, if the customer is stopping to trade and starts to tidy up the business and has a little bit of a break, including refrigeration still be left on, and then a new business starts up, that's important for us to know. Not only can we issue the final bill, but we can also welcome the new customers, wish the old customer farewell and thank them for their business. Customer journey, based on anomaly detection, for the customer benefit, actually for mutual benefit, is now very possible. And it's possible to do that at scale because of the systems that we have in place, and that's what we see as, if you like, artificial intelligence and machine learning in action. Right, so the last thing I wanted to show is how to train those algorithms then, because you may have anomaly detection, but you're not sure if it's actually working or not. So you don't want to link it to an email system just yet, right? Because you want to make sure that you understand your customers and don't annoy them with a degree of process automation. So what we do is we identify only the anomalies that we're more than Six Sigma confident in, beyond any statistical doubt. We surface those to our operations teams, and that means that we have got a low number of anomalies per month, but are very super confident that that is an anomaly. We confirm those algorithms with our customer groups and learn on a manual way if they're working or not. And over time, the amount of anomalies that we can detect and then act on, because we train our algorithms and get higher confidence, is increasing. So that's an example where you see anomaly detection in action. There's a degree of manual intervention required for algorithm training and learning. We try to minimize that, but we would like to look after our customers and not automate topics that shouldn't be automated yet. It's got to be certain. That's our learning process, and I hope you got a couple of examples as to what machine learning looks like in an energy retailer. We're very excited to be collaborating with Amazon, but also InnoWisdom. Made it much easier than I expected, and I hope you will enjoy it too. So thanks very much, and I'll hand back to Steve.
Thanks, Bill. That's great. So I don't have any more slides apart from one more, which is, well, firstly, I want to thank Bjorn for joining us today and sharing that insight. I think that's hopefully really useful for the audience. And if it is, and if it isn't, please share your feedback via the AWS Events app. The AWS Events app is the only way to share specific feedback on breakout sessions today. So if you haven't downloaded that app already, QR code, we'll leave this on the screen, but that's the way to provide feedback for all the breakout sessions today, and we'd really welcome you to do so. Thank you very much.